Hello, this is Miss Goodwin, and today we are covering Objective 3.1, Triangle Congruence Theorems. So the objective for today is that we can determine if two triangles are in fact congruent using triangle congruence facts, including side, 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 angle, side, angle, and angle, angle, side. So we're looking at whether we could tell two triangles are congruent based on the information we are given. So first we are going to look at the first question. Are these triangles congruent? How do you know? Well, we're just given two triangles. We don't know their sides or their angles. So we don't have enough information. So let's look at some notation real quick. So if triangle ABC is congruent with triangle DEF, then we know that the vertices A and D are congruent. So those are the first ones in each one. We know B and E, vertices B and E are congruent. And vertices C and F are congruent as well. So these are all the corresponding vertices in each triangle. And this helps us figure out the sides too. So side AB is this one right here. It corresponds with side DE. So AB and DE are congruent. BC corresponds with EF, so those two are congruent. And CA corresponds with FD. So notice that the common vertices, or the corresponding vertices, are shared between the triangles. And this goes for angles as well. So we have angle A right here. This corresponds with angle D, and if the triangles are congruent, so are the angles. So angle A corresponds with angle D. Angle B corresponds with angle E and is congruent with angle E. And angle C is congruent with angle F. So that's the notation if we know the triangles are congruent. So now, how much information do we need to prove the triangles are congruent? And that's what we're going to look at. We're looking at the congruence theorems. If we just need 3 pieces of information to know if the triangles are congruent or not. And we're going to look at those informations. So the first one is SSS, or side angle side. So side, side, side says that we are given all 3 sides and their lengths. So for example, side AB right here could correspond with side DE here. The ticks, the singular ticks here, means that those sides are congruent. We'll also be given this side as well, BC, which would correspond to EF over here. 2 ticks, those 2 sides are congruent. And last but not least, we have 3 ticks over here. Means those sides are congruent. So the number of ticks groups the sides up by congruency. So if we are given 3 sides, that's enough information to prove the triangles are congruent. So SSS. The next congruence theorem we are going to cover is side angle side, or SAS. So this says we are given 2 sides So let's say AB and DE are the congruent sides. And then CB and EF are corresponding sides. And we are given the angle in between. Now that's kind of the key thing here. We have the angle in between the two sides. So that tells us we are using the side angle side theorem. Side angle side. That is enough information to determine if the triangles are congruent. So we are given two sides and one angle between the sides. Order does matter. Now the triangles can be flipped, so you can have the sides flipped, but the angle has to be in between the same pair of sides. Let's look at the next one. We have angle side. So this time we are given one angle. Let's say angle A and D are congruent. Angle B and E are congruent. Notice I'm using similar notation. One curve for A and D because those two are congruent, and two curves for B and E to say those are congruent with each other. So we are given angles A, B, and DE, and then we are given a side outside of those. So that would be side B, C, and EF. Notice it's next to the same angle here. Oops. That is enough information to tell us that these are congruent. So we are given two angles and one side next or outside the angles. So it's not in between the angles that we're given. Unlike the next one, which is angle side angle. So we are still given two angles. But this time, the side we are given is in between the two angles. So if the side is between the angles, we are using ASA instead. Okay. The last one we are looking at is kind of a special case called the hypotenuse leg theorem. Also known as the right hypotenuse side theorem, but we're going to call it hypotenuse leg. So this is only for right triangles. Keep that in mind. So we know that this is a right angle right here. All right angles are congruent with each other because they're all 90 degrees. So we are also going to be given one leg or side. So let's say we have the short leg here and the hypotenuse. Oops. So we are given one leg and the hypotenuse. For right triangles, this is enough information to determine if they are congruent or not. Let's look at a couple examples real quick. So if we look here, number one, we are asking ourselves, are these triangles congruent? And if so, how do we know? Well, I see one side, another side, and a third side. So this is enough because of the side theorem. And that's it. The next one, we have two triangles, and we are given that side AB and DE are 5 units long. Sides BC and EF are 7 units long. And then we are given that the angles in between, so in this case angle B and angle E, are both 30 degrees. So we have AB is congruent with DE or ED. No, DE, yeah. Angle B is congruent with angle E. And BC is congruent with EF. This is side, angle, side. So they are congruent because of side, angle, side. Okay. Number 3. Now this one, notice that they are sharing a side right here. So this is known as the reflexive property. Which says that a number, side, or angle is always equal to itself, which seems pretty intuitive, but we do have a name for that. So we can use that reflexive property as one of our sides. So now notice here we have side IJ as being congruent with side IJ. We have angle I, or let's call that HIJ because there are 2 angle I's. But that doesn't, but let's come back to that one. We also have side IH, or HI, is congruent with side JK. Now, if we notice here, angle HIJ is in between our sides, but angle IKJ is not in between the sides. So it actually might be more appropriate to put 2 curves there because we don't know if they are congruent or not. And in this case, angle HIJ is not in, or is in between the sides, but angle IKJ is not in between the sides. So if this is the case, we don't have enough information which may be possible. They might be congruent, but we don't know. Because in this case, we are given the side, angle, and side. But in this case, we're given the side, and then the angle. So if you're not given the same pieces of information, we don't have enough information. Okay? Let's look at another one here. Number 4. I see we have LN and QO as being congruent. We have angle N and angle Q. And then we have angle M and angle P. So in this case, we have a side and two angles, which we can just flip around and say angle, angle, side. So we do have enough information for number 4, and they are congruent. Number 5, notice the triangles are connected again. So let's see, we have R and V, or RT and TV. Those two are congruent. We are given ST and TU. And now these angles in between, these are what we call vertical angles, if you remember these from Unit 2. So angle RTS is congruent with UTV, which makes this side angle side. So we do have enough information to prove that number 5's triangles are congruent. And again, the triangles may be flipped, but that's okay. Let's look at one more, and this one's kind of nice. We have a right angle here. Okay. We also have sides WX and YZ. Those are congruent. And then WZ is shared between both triangles. And that is our hypotenuse. So this is what we call the hypotenuse leg theorem, or you could say the right hypotenuse side theorem. Either way is okay. But this is enough information to prove the triangles are congruent. So that is all I got for you. Go ahead, summarize now. How can we prove 2 triangles are congruent? And go ahead, get started on the practice. Have a wonderful day. Bye.